This is the WAVLINK BE6500 network adapter, and I'm going to show you in a minute why you need this network adapter. This is going to change a lot for networking speed and connectivity. So I use this adapter at work, and I use a lot of office products. I do solid modeling in CAD, and if you know CAD, you need a really good connection to the server. You need a lot of computing power, and I can't be spending my computing power trying to connect to the network. So I might do some video editing, and video editing again takes a lot. I'm uploading, downloading to YouTube. I even do a little bit of gaming, and that is very heavily based on network speeds. This has been a game changer. With Wi-Fi 7 and the new technology and this antenna and everything, I am getting really fast uploads and download speeds. So we're going to go into right now why this makes a difference, how much of a difference it makes, and how it can help you with your network. This is my setup for the Wi-Fi test. If I were to test a USB Wi-Fi adapter, I can't do a internet speed test because there's so many limiting factors that limit before it even gets to this point. You've got the type of wiring to your house, if it's fiber, if it's copper, your modem, and then your router, and that all is going to limit. So I was doing these tests and getting a limit of about 250, and I know my network is rated at 300. So I'm running a speed test, and I'm getting just over 200 megabytes per second of speed, but it's the same no matter what adapter I'm using. So what I've done is set up two computers, two devices on my network. I have 4 different USB adapters that I'm going to use on the desktop computer, and I am going to use my laptop as the server, and I'm running this program called iPerf3, or Internet Performance. We're going to test how each of these adapters work from the desktop to the laptop, and that's how you can check your local network speed. The first one I'm starting out with is the TP-Link AC1300. Now this one is not even listed as like Wi-Fi 5, Wi-Fi 6, Wi-Fi 7. It doesn't list it that way. Its maximum speed is 867 megabytes per second. Also, for some background, I'm using my router is a Netgear Nighthawk AC1900. The Wi-Fi is 5. It's a Wi-Fi 5. So I'm already behind a little bit. I realize that, but we're going to test how these things perform on the Wi-Fi 5 network. We're getting transfer of 17.3 megabytes, 14.5 megabits per second. That first test was this TP-Link, and it's a very old one. I could only do the 2.4 megahertz bandwidth. So the second one is the Linksys WUSB 6300, and this one I was able to do the 5 megahertz channel. Now I'm going to do the exact same test and see what our numbers are. Okay, a little bit different, and I'm writing down these numbers so I can see what they mean in a little bit. 23.8, 20.0. This is the WAVLINK AX5400. This is Wi-Fi 6E. And remember, we're still on a Wi-Fi 5 router. It's a pretty cool network adapter. It's got the light on it, so you can see that it's working. You can also turn it off if you don't want that blinking. So we're gonna try that. We're starting to get in some pretty big numbers relatively, 55.5 and 46.5. And the last one I'm going to try is the WAVLINK BE6500. This is Wi-Fi 7, and we need to get this installed. I've got my last network adapter installed. This is the WAVLINK Wi-Fi 7 BE6500 tri-band US 3.0 wireless adapter. Okay, 69 megabytes. 57.8. So we have tested 4 devices now. I have all 4 devices here. On the fastest one, which is the, and it makes sense. This is Wi-Fi 7, it's new technology. There's reasons that it's gonna be faster even on a slower network. Since my router is Wi-Fi 5, my laptop is Wi-Fi 6, and this adapter is Wi-Fi 7. We're not going to see this potential on this test, but it should show some improvement, which we did. We have 69 megabytes. There are 8 bits in a byte, so we're going to multiply that by 8. So 69 times 8 equals 552 megabits. It ran for 10 seconds, so we divide that by 10, and we get 55 megabits per second. And that matches what it reported up here, pretty close. Wi-Fi 4 is 50 to 150, Wi-Fi 5, 200 to 400, Wi-Fi 6, 400 to 800, Wi-Fi 6E, 600 to 1000, Wi-Fi 7, 1 to 5 gigabits per second, theoretical. So the problem that we're having is my network is Wi-Fi 5, this server for the test is Wi-Fi 6. So we're limited, but what I wanted to show was the relative difference in speeds. And when we look at the difference between 17 or 23 to 55 and 69, that's a 4 times difference. So before I did this, I thought every network adapter was the same. So why would I pay this much for an adapter or more when I could get one for this much? Well, this is why. That is 4 times. This one at 46.5 divided by 20. This one's 3 times faster than this one. These, I'm not even going to use these. These are going away. These two are very compatible. The Wi-Fi 7, even though I'm on a Wi-Fi 5 network with a Wi-Fi 6 server, this WAVLINK adapter is still faster than the other WAVLINK adapter. It's 125% faster, but this is Wi-Fi 6E, this is Wi-Fi 7. There's different technologies, different things going on. Just in the hardware alone, you can gain percentage. Depending on how much you want to pay, what your network is, it may not be worth it to go here if this is good enough. So some things to consider. Definitely look at the specs, think about your system. You may need to upgrade your router to fully use these. Like Wi-Fi 7, now I'm thinking I need to upgrade my router because all of my devices have faster network speeds. That is demonstrating the WAVLINK Wi-Fi 7 BE6500 network adapter.